everybody, this is Freya and welcome to the Mathly.org YouTube channel. Today we're going to go over a problem from one of our high school sprint rounds this year, namely 12203 Sprint 16. So the problem states as follows. Let x be a complex number. In other words, x is equal to some form a plus bi, and I is the square root of -1, and not equal to 1. So that means that x is not equal to 1. Such that the following equation holds: x cubed minus 2x squared plus 2x minus 1 is equal to 0. So this here is our constraint. Compute the sum of the squares of the magnitudes of the possible values of x. So recall that the magnitude of a complex number x, denoted by this absolute value sign, is equal to the square root of a squared plus b squared. However, we want to find the square root of the magnitude, so our magnitude squared is equal to a squared plus b squared without the square root. One thing to note is that the magnitude is always strictly non-negative, greater than or equal to 0. All right, so we have our polynomial x cubed minus 2x squared plus 2x minus 1 is equal to 0. One thing that's going to be nice is that we want to factor this polynomial. So we can do so by factoring by grouping. So that means just grouping two terms together. In particular, we can note that x cubed minus 1 minus 2x times x minus 1 is equal to 0. So the reason why we wanted to use this sort of grouping, why we picked our numbers here, is this constraint that x is not equal to 1 kind of suggests that we might want to look into factors of x minus 1 somewhere. In fact, we know from difference of cubes that this x cubed minus 1 is equal to x minus 1 times x squared plus x plus 1. And that here has a factor of x minus 1. And similarly, we have our 2x times x minus 1 is equal to 0. And this thing here, this is from here. All right, cool. So since x is not equal to 1, we want to go through and cancel stuff out. So we will cancel and cancel. And therefore, we are left with x squared plus x plus 1 minus 2x, which is equal to x squared minus x plus 1, and that's equal to 0. Now, remember our difference of cubes. We had that x cubed minus 1 is equal to x minus 1 times x squared plus x plus 1. Now, this may remind us of what we have here, just as a sign is flipped. And in fact, that will prompt us to use sum of cubes factorization, namely x cubed plus 1 is equal to x plus 1 times x squared minus x plus 1. So it's the same sort of factorization, it's just a different sign. So what that means is over here, both values of x satisfy x cubed is equal to -1. In other words, our values of x are cube roots of -1. So what that'll now tell us is that, well, they satisfy our magnitude of x is going to be equal to 1. Note it's positive 1 because magnitude is always strictly non-negative. And we want to find squares, so that means that for our values of x and magnitude squared is still going to be equal to 1. Now, let's look at the degree of our polynomial. We have it as degree 2. We started off with degree 3, but because we are excluding x equals 1, that's one fewer root, and we have 2 left. So our final answer is going to be the sum of the magnitudes of both of these roots, which is 1 plus sum of the squares of the magnitudes. Well, the magnitudes and the squares are the same, and that's going to be equal to 1 plus 1 is 2. And there we go.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.